You can copy these down. This is going to be for the big analysis. The big analysis, we're not testing for ammonium, but there's going to be ammonium there. There's silver, lead, barium, and manganese too. So we have these 5 cations here. So the first step in this is we're going to add our excess HCl solution. With the HCl solution, we're going to precipitate out both silver chloride solid and PbCl2 solid here. And so what's the reaction here? The reaction here is going to be silver ions, like chloride, to precipitate out silver chloride. This is like a double replacement reaction, except the spectators aren't shown. So it's net ionic. So rather than calling it double replacement because it doesn't fit that form, we just call it metathesis. Metathesis reactions are just favorable ion combinations, like this. Silver and chloride form a favorable combination. Lead 2 and 2 chlorides form a favorable combination. However, ammonium and chloride, this does not form any precipitate, any gas, or any weaker acid from a stronger acid. So there's no driving force for this. So there's no reaction here. Barium ions and chloride, also no reaction. Manganese and chloride, this is no reaction as well. So for the report for this, you'll just turn in a copy of this, all the reactions, all the equations for this, and then you'll list your the ions that you found. And so those are the white precipitates. You're going to get the observation. And then what we're going to do is we're going to heat this up. Delta is the symbol for heat. And what's the heat going to do? Yeah, it's going to dissolve the PbCl2. We got to make sure we get it all to dissolve. So usually crush it with a stir rod or something. Just make sure it all dissolves. And then we get it back in solution. So we're going to have Pb2 plus, ammonium, barium, and manganese in our filtrate. And then we got to make sure we wash our silver chloride. And so in this particular reaction, we have PbCl2 solid plus heat and water. And then we get PbCl2 aqueous. PbCl2 aqueous is going to be a strong electrolyte when it's dissolved. And so what PbCl2 aqueous is Pb2 plus and 2 chlorides. And so we get the Pb2 plus back in solution here. And then the silver chloride isn't going to do anything. So when we do the silver chloride solid plus the heat in the water, we just end up with silver chloride solid. You know, a tiny bit does dissolve, but that tiny bit is negligible, so we don't really worry about that minuscule amount that does dissolve. So this is pretty much it here. Okay, then we're going to treat our silver chloride solid with sodium hydroxide. Just dump it in there. And in this case, we're going to go to the silver oxide solid. This is black. And so the precipitate turns black. And so in this particular reaction, we're going to have silver chloride solid. Oh, actually, do we dissolve it? No, I don't think we dissolve it. In the flow chart, you just add the sodium hydroxide straight onto the solid precipitate. And we could dissolve that precipitate, but we aren't at this point. What happens here is the silver chloride plus the sodium hydroxide, what that's going to yield is it's going to yield silver hydroxide plus sodium chloride. Silver hydroxide is a solid. This is not enough to drive this reaction. And so in the second step, we're going to have to take 2 of the silver hydroxide solids, and then that's going to convert into Ag2O silver oxide solid plus H2O liquid. And so it's a 2-step thing. So we're going to double the first one, everything here. So 2 silver chlorides plus 2 sodium hydroxides makes 2 silver hydroxides plus 2 sodium chlorides, and then 2 silver hydroxides decompose into silver oxide and water. So that would be the reaction for that. Okay, then what are we going to do to this filtrate here? The filtrate is the liquid part of the solution. And so you'll either have a glass funnel or a plastic funnel when we do this. And normally what I use is a clay triangle to support the filter, or a small ring, or both. You know, actually we need both to do this. And then we just support it on a ring stand. So this is the filtration apparatus. And then I need some filter paper. The filter paper we usually have in a box. Let's see. There's filter paper back here. Yeah, it's in a box back here. It's just a round piece of filter paper. So we need to get this to fit into the funnel here. And the normal way people do that is they fold it into a quarter. So fold it in half and then fold it into a quarter. And then what people do is they'll put 3 layers of filter paper on one side, 1 layer on the other side, and then jam it in there. Some people tear off a piece on the end, you know, tear off a small piece. I don't understand that. I mean, I did it, but I really never got why I do that. And so I stopped doing it. And I just put the filter paper in here, but it doesn't want to sit in there. So it doesn't want to sit in there. I just get a little bit of DI water. Make sure that it's not tap water, DI water. And then just wet the filter paper so that it adheres to the funnel. This is kind of what you do with the red litmus. It's going to adhere to the bottom of the watch glass here. And so this is the filter paper. Now, when we pour solutions in here, let me just show you how we pour solutions. So let's say this is cloudy with precipitate here. If it's cloudy with precipitate, then what you want to do is 2 things. One, either stir it up and dump it in here. But if you stir it up and dump it in there, it tends to clog the filter paper more quickly. And so normally what we do is we don't stir it up and we just pour this. But we need there are 2 beakers that you're going to have under here. One beaker is going to be for your filtrate. The other beaker is going to be for your waste. So you got to make sure you have the right one under there. Let me rotate this. Yeah. Let's see if I have it lined up. Maybe. And so normally when people pour liquids, they use a stir rod like this. And then just use the stir rod here. I'll exaggerate. You use the stir rod to direct the stream of the liquid. And so something like this. All right, that last little bit in there, we usually wash out. That's your first wash. And so what's going to happen is there's going to be precipitate stuck on the inside of this and at the bottom. And so you use a little bit of the wash. The first washing is going to be hot water. So you'll get a little bit of the hot water in there, And in this case, you want to stir it up to make sure you get as much precipitate over as possible. And so that's your first wash. You're going to catch that in the filtrate. Okay, there could still be some stuff stuck in here. And so your second and third wash, we switch it over to the waste beaker. Usually we use a big beaker for the waste. The waste jug is back there, and so I don't want to be walking back and forth continuously. So put the waste beaker in there. Your second and your third wash, you can really use a lot if you want to transfer it over. Right. And so second, third wash to transfer it over, and also to wash the precipitate inside the filter. It's called your filter cake. This is your filtrate, your precipitate, and your... They also call this solution here the supernatant. You can hear that. So filtrate or supernatant. All right, so we got this cleanly separated. Clean separation is what we want. Clean separation is going to give us good results for this. Okay, the next step is we're going to add, what are we going to add? Bisulfate? What's the next step in the flow chart? Potassium iodide. All right, now what's going to happen is as the filtrate or the supernatant cools down, what do you think is going to happen? If this cools down, lead 2 chloride is going to precipitate. So if you see a white precipitate forming here, heat it up. Do we have hot plates in here? I might get some hot plates. Let's see if there are hot plates available. If not, unfortunately, we'll have to heat it up on the burner. We'll have to heat it up in a hot water bath. If there's no hot plate, then what you want to do is you want to set up a hot water bath immediately. This is the first step that you'll do. You don't want to use the biggest beaker for your hot water bath because sometimes we have to use a small test tube. So sizing it up, this is probably good here. Like a 250 or 150. 250 or 150 would work well. And then we'll set up a hot water bath here so you can have your solution. Yeah. So the Ki has to be added when the lead is aqueous, not when it's a PPT, preferably. And then what we're going to get is we're going to get PBI2. Solid. This is a yellow precipitate. And so the reaction here is Pb2 plus 2 iodide yields PBI2. Solid metathesis reaction. And then when we look at the others, like for example, ammonium plus iodide, Nr, no driving force. Barium plus iodide is an Nr. Manganese plus iodide is an Nr. So same thing here, we need to transfer all the precipitate over. You're going to use multiple rinses probably to do that. In this case, it's okay. But only the first rinse or wash you'll capture in the filtrate. So the filtrate should now contain ammonium, barium, and manganese. Okay, same thing holds here. Make sure we precipitate out all. And so to make sure we precipitate out, sometimes what we'll do is we'll just test it one more time. And so, yeah, we filtered this, but, you know, just to be sure I got all the lead out, I'm going to add 1 drop of potassium iodide to this and see if I get precipitate. If I continue to get a precipitate here, then I wasn't done. Filtering is kind of nice because after you filter it, this filtrate should be nice and clear. Over here, this is going to be a little bit more difficult. We can do the same thing over here by adding 1 more drop of HCl. just to make sure, but you got the lead there, which can precipitate out with the HCl. Over here, nothing should precipitate out with the iodide. And so we just add one more drop to test. Because the reason is if lead passes through here, it can interfere with subsequent tests, especially the next one. What's the next one? Yeah, sodium bisulfate. The lead will precipitate out with sodium bisulfate also. And so here we'll add the sodium bisulfate, which is going to precipitate out what? Barium sulfate. And so the reaction here is this barium 2+ plus bisulfate ion. Sodium is a spectator. This hydrogen doesn't break off so easily. You know, it's a weak, bisulfate's a weak acid. But barium can knock it off. And so barium knocks off that hydrogen, so that it can precipitate with sulfate, and we're left over with the H+ over here. Ammonium and bisulfate, NR. Manganese and bisulfate, NR. So the same type of deal. Now we're left with ammonium and manganese. There's other stuff. Of course, there are anions, chloride, whatever else. There's a bunch of other stuff in here, iodide. But these are the two main ones we're looking at. Okay, then what do we do? We add sodium hydroxide here. The sodium hydroxide is going to precipitate out the manganese. So the precipitate, do they write it on the right or the left? I can't remember. On the right. So the reaction here is pretty straightforward. The reaction is just manganese plus 2 hydroxides yields a precipitate of manganese 2 hydroxide. Solid. Ammonium also reacts with hydroxide. Ammonium plus hydroxide makes what? Ammonia and water. This one we want to clean this precipitate very well because we don't want the ammonia to go over there. And so the ammonia is over here. We need to clean this precipitate well because we don't want ammonia contaminating this. Because ammonia is going to screw up the next step. What's the next step? Add nitric acid. And what else? Well, actually, what's the nitric acid going to do? Well, let's continue it over here. Nitric acid is going to dissolve my precipitate. So I'll form Mn2+ over here. So the precipitate dissolves. Magnesium, manganese, not magnesium. Manganese 2 hydroxide plus nitric acid. The nitrate's a spectator in this case. We'll just do 2H+. This is going to yield Mn2+ plus H2O. Actually 2H2O liquid. This is a double replacement. You could do it in double replacement. Just rub an anionic form. There. And so hydroxides like acid to form water. Okay, then after this we do what? Then we add sodium bismutate. sodium bismutate is what? NaBiO3?
Yeah.
And what is it?
It's a solid.
It's a solid.
It's like a powder.
Looks like a bad powder. It's very hazardous. Next to the filter paper is a bottle of sodium bismutate. The sodium bismutate I'm going to move into the hood. One time I was doing this lab and I looked over there and there's a big brown dust cloud there. And the person was just standing, they didn't even care that they're inhaling sodium bismutate. Sodium bismutate is a very powerful oxidizer. It's dangerous stuff. And so, yeah, I'm going to move it into the hood in case the dust cloud forms and gets sucked into the hood, which would be better than breathing it in. Sodium bismutate, it's a sodium salt, so it's going to dissolve. And what we should get is a purple liquid, and that purple liquid is going to be permanganate, aqueous. It's not a precipitate. Sometimes people add a lot of this and they think they get a precipitate. There's no precipitation in this step. It's just converting this one, which is almost colorless, to a deep purple color. This one, manganese 2 plus, is light pink, and it's really hard to see. This one's really easy to see. And so what's the reaction here? The reaction here is manganese 2 plus bismutate. Sodium is just a spectator. What's the charge on bismutate? -1. Yields permanganate plus what do you think bismutate gets converted into? Maybe bismuth 3? Probably. Bismuth 3 or bismuth 2 or something. And so what this is called a skeleton redox. It just shows the major species. It's not balanced. In chapter 19, we'll learn how to balance these so we can figure out the rest of this. But essentially, the manganese gets oxidized. Here, the oxidation state is +2. What's the oxidation state of manganese in permanganate? Yeah, +7. So to go from +2 to +7, it lost 5 electrons. We need a powerful oxidizer. This is a powerful oxidizer. All right, any questions? This is the first part. I'll talk about the other reactions next time. Okay, no questions? We'll go ahead and get started.